skid steer that won't do anything, a battery reading full. The whole fix was one corroded ground nut. So why does a machine with perfectly good voltage act completely dead? And what can a meter actually prove? Today, electrical faults on the S175, dead circuits, relays, sensors, and the point you need the wiring diagram. Start where the machine already talks to you. The hour meter doubles as the code display, and it keeps notes. If more than one service code is stored, the codes scroll through that display one after the other. That scrolling matters. People read the first code, start wrenching, and never see the two sitting behind it. And the second code is usually the one that explains the first. Here's what that looks like. Say the display shows 3265, sensor supply voltage out of range. That isn't one sensor failing. That's the feed every sensor shares. Chase the one sensor that complained and you'll be there all afternoon. Which gives you the rule for this whole video: a code is an address, not a culprit. You'll see people online decoding the number pattern. This digit always means this. That ending always means that. Don't. Code meanings differ between machine generations, and the table for your exact machine is the only one that counts. Two codes can look like a matched pair and mean completely unrelated things. Look each one up, every time. Now, the meter. Most people use it wrong, and not with the wrong buttons, at the wrong moment. They probe a dead circuit with everything switched off, see battery voltage sitting there, and call the wire good. But a bad connection still shows full voltage when nothing's moving. It only fails when something asks for current. It's the difference between a chair looking sturdy and a chair actually holding you. One test proves nothing. So test it loaded, switch the circuit on, then measure across the connection while it's genuinely doing work. One probe each side of a connector, a splice, a ground stud. You're measuring what that joint steals. A healthy connection takes almost nothing. A corroded one eats the voltage before it ever reaches the part. The service manual lists the exact acceptable values, but the shape of the test never changes. Stock with grounds, the manual says it flatly, corroded, or loose grounds cause these symptoms, so check grounds. Ground faults are liars. They make a good sensor look broken and a healthy relay look burnt out. And that's exactly how the most misread code on this machine fools people. Watch what it actually means. 39 is battery voltage low. Obvious, right? Bad battery. Except the battery is very often completely fine. That voltage is measured at the controller, not at the post. Everything in between gets to skim off it. Corroded terminal, tired cable, loose ground strap. The controller reports what reaches it and less is reaching it. Now here's where it flips, because the same misreading runs in the opposite direction too. 310, battery voltage high, isn't pointing at the battery at all. It's pointing at the charging system. The manual has a whole charging system check written for exactly this. Run it before you buy a single part. So the reframe, most so-called electrical failures on these machines aren't failed components, they're failed connections. If that just saved you a parts order, that's exactly what this channel is for. Stick around. Relays next. A relay is a switch that a small circuit closes on behalf of a much bigger one, which means every relay has two circuits inside it and both can fail. Most people only ever test one. The control side takes a trickle. The load side carries the real work. Different failures, different tests. The swap test is free. Find an identical relay running something you don't need right now and trade them. Fault follows the relay? It's the relay. Fault stays put, you just prove the relay innocent for nothing. That's 5 minutes and $0, and it clears the part everybody guesses first. One catch, relays that look identical aren't always identical inside. Check the part numbers before you trust the result. Now the circuits that strand people in a field and the ones that get the most parts thrown at them. The interlocks. The circuits that quietly decide whether this machine is willing to move at all. The loader feels dead. Engine running, lights on, everything looks alive, nothing responds. That's usually a lock circuit. 11.6 is seat bar sensor short to ground. In plain terms, the machine thinks nobody's sitting in it. But it isn't necessarily the sensor. A wire rubbed through against the frame reads exactly the same way. That's the trap. Short to ground names an electrical condition. It never names which part caused it. Its twin, 11.5, is seat bar sensor short to battery. Same circuit, opposite fault, same detective work. The controls get their own version. 3261 is handle lock short to ground, and the pedal lock has its pair. These circuits run through the parts of the machine that flex, pivot, and get stepped on all day long. So look where the harness bends. Under the seat, along the cab hinge, anywhere something moves against something else. Wriggle the harness with the meter connected and the circuit live. Watch for the reading to twitch. It's the charging cable that only works at one angle. The brake is real. It's just shy about it, which is why these come back. Intermittent faults heal themselves the second you park it in the shop. Sensors and solenoids get blamed constantly, and they're usually the last innocent part left in the chain. 24.2 is rear rod solenoid error, ON. It means the controller expected one state and measured another. Could be the coil, could be the wire, could be the connector that's been packed with dust since spring. You can test a coil with the meter alone. Resistance tells you whether that winding is still in one piece. But resistance can't tell you whether the controller ever sent the command. That's a completely different question. And there's a fault type where even a perfect coil test tells you nothing. The table warns you about it. Read it closely and it separates the two for you. There's a code for a tilt actuator fault, and a separate one, 3232, for a tilt actuator wiring fault. The machine can tell those apart. That's a gift. When the table names wiring, stop testing the part and start testing the path. So where does the meter genuinely run out? The line is sharper than most people expect. A meter tests one thing between 2 points you chose. It's only ever as smart as your guess. The moment a fault involves a shared path, a common ground, a splice feeding 4 circuits, guessing collapses. You'll know it by the symptom. 2 unrelated things quit together, and nothing on the machine connects them. On paper, they share one ground point. You would never find that by probing. It isn't visible from outside. That's the diagram's real job. It isn't the test. It's the map telling you which 2 points to test. Second trigger, a code naming a controller. 32.4 is ACS not communicating with Bobcat controller. Now you're not chasing a wire, you're chasing a conversation. Power, ground, and the network carrying it. Third, 3648, ACD multiple controllers present. That's a configuration problem and no amount of probing will fix it. And the manual is blunt about the rest. Some of these checks belong to authorized Bobcat service personnel. Not because it's mysterious, but because a wrong move here costs a controller, and controllers aren't a cheap lesson. So here's the honest split. The meter owns everything you can reach and load, grounds, connectors, coils, relays. The diagram owns everything shared or hidden, splice points, common grounds, module feeds, and the network between controllers. Do them in that order and you'll solve most of these before the paper ever comes off the shelf. Before you condemn anything, read every scrolling code, clean and load test the grounds, then measure the path under load. A code is an address, not a culprit, and a wire that looks perfect can still starve the part it feeds. Subscribe for daily diagnostics. Next one, the filter codes on this machine, and what not connected really means. The exact test values are in the service manual linked below. Like this, if it saved you a guess. Now go find your bad ground. It's behind the seat, it's green, and nobody ever photographs it.